โอเคค่ะ สวัสดีค่ะทุกคนนะคะ ไม่ได้ทำ lead code มาสักพักแล้วนะคะ เดี๋ยววันนี้จะมาฝึกทำแล้วก็แน่นอนจะพูดเป็นภาษาอังกฤษนะคะสำหรับวิดีโอนี้ โอเค Hi everybody long time no working on lead code with I usually I work with my friends like try to do every week, but I will say that I didn't really have like motivation to do it. So I gonna come back and try to do it more often now. With I already add to my schedule. So let's get with the easy one with I focusing on the three binary trees. Okay, so this one is maximum depth of binary tree. Let's get reading and then we're gonna continue to do it. Let's get started. Okay. Okay. Where's that? Okay. Let's read the problem together. The problem on lead code with maximum depth of binary tree. Okay. Giving the root of a binary tree, return is maximum depth. A binary tree is maximum depth is a number of nodes along with longest path from the root node down to the farthest left node. So let's go to see the example. So in this problem, we have root. The root node is 3, and then we go to the left, only one level, right? And then we go to the right. So we have 1 and 2. So what is that means? Okay, we return 3. So that means we want to find the maximum depth of binary trees. Mean we want to go either left or right, and then we compare which one is it the maximum number, either go to left or right. I think in this case we can use pre-order, which is gonna go either like from the root, right? So let me just write down my pseudocode here. So we know in that case, I think we can solve problem either the first, because I think I'm gonna go with the first solution. So because we're gonna have to go deeper, not go like each level. I think also we can do with, but first let's try to see which is I can do first. So this is easy problem, but since I didn't really work for a while, so I forget. So let's say, so gonna go with that first. So we're gonna have to base case, right? Our base case will be check if no root, we're gonna return 0, and then we're gonna use recursive to travels through left and right nodes, and then compare with find the most maximum. Okay, so that's what my plan, and then the time complexity gonna be O of n, because we're gonna have to go using stack to recursive call on its left and right. So let's just jump in now. So my base case will be if no root, we're gonna just return 0. And then we're gonna travel to left and right. So we have the method from JavaScript to use. So I'm gonna say compare, which is max, which we're gonna travel to left and right. Each iteration will be, we're gonna travel to left and compare to the right with the right, IGHT, which is, that should be, this is compare, but on each iteration, we're gonna increment by 1. So then we want to go to left, right, and then go to right. Then we want to increment by 1. So then we find the most maximum one, which is like, let's say we go to the left, so we increment left side. So that's what we return 1. So it's gonna be 1. And then we start from root, so we one increment is gonna be 2 on here, right? And then we go back, we come back to root, and then we go to the right. So on the right node, we have 20, which we're gonna to left and right, right? So we go to left, so we turn 1, go to right, we return 1, and then while we iterate through the root, it's gonna increments by 1. So this one return 2, and on the right, we're gonna return 3. Then we compare 2 and 3, so we should return 3. So that is my solution. So let's go and run if that passed. Okay. Okay, that passed. Okay, then submit. Okay, so that passing. So let's customize what is the time and space here. Okay. Okay, that is good. On lead code now they have what's that called? Okay, so the time complexity will be all n times because we need to as much as uh node deeper, so that's why we increment. So the time will be O of n. The space also will be O of n because we're using stack to store on each node when we go down and then we return at the end. So that's it for today. I think, let me think. I have another problem. I have 15 minutes. So let's go to the other problem. Let me stop to share and then I will share another problem with a gonna work. Okay, so this is good for the first solution. Oh, okay, so let me stop right now because I have someone calling me. Thank you for watching.